Hello Year 11 and welcome to this tutorial video which will talk you through the product design exam. So please watch, pause and rewatch sections as you see fit. There's going to be tips throughout and this should hopefully prepare you nicely for the exam. Where can you find resources to help you revise in the last few days running up to your exam? If you go onto your Microsoft Teams class and in the Files tab, there should be a folder Class Materials, Revision and Exam Prep, and there'll be something called June Exam 2022. So have a look in there. There's lots of stuff in there, including the topic list in case you've lost that. That breaks down all the topics that you're likely to be tested on, including web links and page numbers for your revision guide. There's also a PowerPoint with lots of text and notes on some of the topics we've been revising that are likely to come up. There's a hint sheet for the exam, giving you lots of advice on how to go about answering questions. And most importantly, please check out an exam paper I've put together. This is in the style of the paper you're likely to face, including questions and mark schemes on those topics. So really important you check that out more than anything. Please do have a look. So how's the paper structured? Section A of your exam is worth 20 marks and that's on core technical principles. This features lots of low mark questions, some of them multiple choice. For example, questions like this: which of the following textiles comes from a renewable source? Okay, the first thing to do is read the question carefully and look at the word renewable. What does that mean? Well, it means it's got to be natural, probably biodegradable. Look at the answers then: polyamide, which is nylon, polyester, elastane or cotton. Well, use a process of elimination and you realize polyamide and polyester, poly, they're probably polymers, they probably come from oil, therefore they're not sustainable. So you can pretty much rule them out. And then you've got two options left: elastane or cotton. Think which of those sounds natural. The answer is cotton. And when you're clear on that, make sure that that's clearly marked. Another natural fabric would be wool. So tip number one is read the question carefully and use a process of elimination to go through the answers. Here's another example. Which of the following boards is most suitable for food packaging? Right, inkjet card. That is obviously for printing, so that wouldn't be suitable, so I can rule that out. Duplex board, could be that. Carton board, that's a good hint that that might be used for cartons of something, could be food. Bleed proof paper, that's a possibility as well, because I think you wouldn't want food to leak out, that'd be kind of like bleeding. Then cartridge board, well, cartridge, that sounds a bit different, that sounds like it's an art-based material, which it is, so I'm going to rule that out. Then you've just got to go with your best guess. Now, bleed proof paper is actually it stops ink running, so the option that's remaining is actually duplex board. So again, it's using this process of elimination. Here's one final example. Which of the following is an input device? A light emitting diode. Well, if it's emitting light, that's an output signal, so it can't be that. Thermistor, maybe you're not familiar with words like that. Don't know what it is, we'll leave it for now. Microprocessor, I think that's something to do within a system. Not sure if that's an input though. And speaker, well, a speaker, again, that's making a noise, that's going to be an output, so it can't be that. So then you're left with thermistor and microprocessor. Well, if you know anything about systems, a microprocessor is like a brain, so it's not going to be that, which leaves the one that you're probably not familiar with, thermistor. So that's what I'm going to mark. Just so you're aware, a thermistor is actually an electronic device whose resistance changes depending on the temperature. So that's going to be an input for a system. So tip number 3, if in doubt, just go with your best guess. Do not leave it blank. You always have a chance of getting the mark if you just guess. Okay, section 8 also features some low mark questions in which you have to explain key concepts. So you might have a question like this: explain the term thermochromic pigment in relation to smart materials. Again, read the question carefully. Thermochromic, thermo must means heat, pigment has something to do with colour. Now if you answered something like this, a smart material like thermochromic pigment changes colour, you probably have made a simple point there, so you're going to probably pick up 1 mark. My advice is be a bit more detailed and specific and show your true understanding of all these topics. So for example, a better response would be something like this: Thermochromic pigment is an example of a smart material because it changes its properties in response to an environmental stimulus. That would get you 1 mark probably, i.e. it changes its colour in response to heat. That would probably get you the 2nd mark. And then this could improve the function of a product, e.g. a spoon that indicates if a toddler's meal is too hot. There's an example, so it's definitely going to pick up 2 marks now. So tip number 4, justify and fully explain your points giving examples. Note the number of marks available. If it's more than 1, it's probably looking for a justification or an example. Section 8 may have some fairly simple maths questions. So imagine this was the question. A company manufactures products at a cost of £9.60. They want to sell each product at a price of £12.49. What is their percentage profit? Now again, look at the number of marks. 2 marks here, so we're going to have to show 2 steps. Now you might not be confident in some of these maths topics. Let's say you're not good at percentages. Well, at least have a go. Profit, what does profit mean? Well, it's the money you make. So a simple formula would be the selling price minus your costs. If you just showed that, if you just showed the little bit of working that you might know, you can get a mark. In which case the profit here is £2.89. But let's look at the question. We need to know the percentage profit. The actual formula for percentage profit is profit divided by cost times 100. So it's the ratio of profit to cost times 100. And if I put the numbers in, I've already calculated profit as 289. The cost was 960 times 100 gives me this number. So my tip number 5 is when you're completing maths questions, show your working, or at least show your attempt. Okay, if you're stuck, then move on, don't waste time, but at least show your attempt, show your working. And tip number 6 is underline your answer and round to a sensible number. Here I've rounded to 1 decimal place so that it's not a really long answer. Okay, there may also be maths questions related to areas and volumes. So for example, the cylinder has the dimensions shown, calculate the volume in millimeters cubed, assume pi equals 3.14. There's 3 marks here, so we need to show probably 3 steps, 3 bits of working. Now be careful when you've got questions about areas and volumes, because notice that the units here are actually in centimeters, but the question asks for it in millimeters cubed. So the first thing to do, we need to get in the correct unit. Notice as well that this symbol, a circle with a line through, actually means diameter. And if we're calculating something to do with the area of a circle, then it's radius we need to think about. So I'm going to convert the units first. 16 centimeters is 160 mil, 8 centimeters is 80 millimeters, and the radius is what I want, so I'm going to halve that diameter, so I know the radius is 40. The volume of a cylinder is the pi r squared times height. Okay, you've got to work out the area of the circle and then times the height. So here 3.14 times 40 squared times 160 gives me a rather large volume in millimeters cubed. Again, underline the answer, make it clear, show the unit. So tip number 7, if a maths question asks you to calculate areas or volumes, convert to the required unit first. In this case it's millimeters cubed. Moving on to section B of your paper, this is on specialist technical principles, worth 30 marks. And this contains higher mark questions that relate to specific material areas you've studied, for example polymers, timbers and metals. Just a word of warning, you might have the option of answering questions about textiles or electronics. We've generally not taught you about them. Focus on the material areas that you know about and you've revised. So here's an example. The following are examples of manufacturing processes. Indicate if there are wastage, redistribution or fabrication processes. So we need to be familiar with technical language here. A wastage process is one where material is removed from a stock form. A redistribution process is where material is reformed into a different shape, usually by melting. And a fabrication process is where a product is assembled from multiple parts, usually stock forms or standardized components. On that, let's look at the first one. The example is welding, soldering or dowel joints. Of those, it's things being brought together, it must be fabrication. For injection molding or die casting, what do we know? Well, Injection moulding is where you melt plastic pellets down and inject them into a mould. Die casting is where you melt metal down and it's forced into a die. They have to be redistribution processes, leaving drilling, turning and die cutting as wastage. Another one that you could be asked for is an addition process. That would be something like 3D printing. So tip number 8, complete all the required tables. I've noticed students in the past not realise they have to fill out a table, so make sure you do. And tip number 9, be familiar with and use key terminology. So you'll need to look up language in your revision guide, make sure you're familiar with it. Section B also has questions where you have to sketch and describe a process. In this example, it wants you to sketch or explain a wastage process. You're going to have to name one. So if I give you an example, for example, of turning on the wood lathe, if I were you, I would just do one simple sketch, okay, because it's going to save you time. If you can, label all the parts that you know. For example, on the lathe, there's the headstock, tailstock, tool rest, and there's a spindle where you put the workpiece. And if you think back to when you were in lower year groups, you would have used this. Then, to get the 5 marks, you need to describe the process. At the moment, you've probably only got 1 mark for a little sketch. So go through. Always mention marking out. For example, using a marking gauge, steel ruler, sharp pencil. Whatever the process is you're describing, you're probably going to have to say marking out first of all. For turning, you need to saw the V-shaped notch in one end where it's going to be mounted on the spindle. You also have to shave the corners off using a wood plane. You probably remember that. Securely mount the workpiece lined up centrally between the spindle and tailstock. If you make a point like that, you're showing awareness of safety and also quality control. And that's what the examiner wants to see. Check the piece is secure and the turning speed is correct. This is true if you were drilling. You could make sure the workpiece is secure, make sure that the speed of the machine is correct. It's the same with laser cutting. You need to make sure that the power and speed settings are correct. So if you were describing laser cutting, you could use similar language. Mention safety, for example, goggles, an apron and no loose clothing. That would be the same for other processes in the workshop. Worth mentioning, no loose clothing. Turn on dust extraction. Again, it's a safety point. If you were using toxic substances, you'd want to mention working in a well-ventilated area. The examiner will be impressed if you talk about working in a well-ventilated area. And then finally, turn on the machine and gradually move a wood turning chisel along the length of the piece, finished by sanding. So here we're mentioning specific tools. Please do that. In this case, a wood turning chisel. So tip number 10, if you're describing a manufacture process, add 1 annotated sketch, maybe 2, with step-by-step instructions including quality control and safety. That's how you get the marks. Right, towards the end of section B, there's likely to be a longer written question worth 8 or 10 marks. This is where you can pick up a lot, and this makes a difference between a whole grade. So imagine this as your example question. Analyze and evaluate the environmental and ethical issues a designer may consider when designing a new product. Give examples of what they can do to minimize their impact. 10 marks. Now, when you've got this long written answer, my suggestion is mind map your initial thoughts. You could put words around the question. So I would think, right, environmental and ethical. What are my thoughts there? I could mention climate change, carbon footprint, harm to wildlife, biodiversity, which is basically decline of species, deforestation, oceanic pollution, use of non-renewables. Right, that would be enough for now, I think. Ethical issues. Ethics is basically impacts on people and society. So I might think of worker rights, safety of products, safety of people. And I might think of cultural impacts, cultural sensitivity. Right, so there's enough issues certainly to discuss in my little essay. The second part of the question, notice, is give examples of what you can do to minimize impacts. All right, so again, mind map your initial thoughts. You might describe choice of materials, choice of manufacturing processes, environmental extraction processes, recyclability and repairability of products, carbon offsetting, life cycle assessments. And for ethical issues, you might think about fair trade, safe and fair working conditions, and supporting local communities. So, for extended written answers, mind map your initial thoughts. Don't spend ages on it, but just get some words down which are going to help structure your answer. So here's a model one that you could go with. I'm not going to read all of this, I don't think. I'm going to let you pause it if you want to, but you could start with a little introduction, like here, designers have a moral obligation to consider their environmental and ethical impact of their products, blah blah blah. Let's start with the big ones. An important consideration is the impact of climate change, because this threatens our long-term survival and quality of living for future generations, impacted by processes like burning fossil fuels, deforestation. Other considerations are atmospheric and oceanic pollution, which threatens wildlife, biodiversity and health of society. Good, I've got quite a lot of issues down there now. Okay, now you can move on to giving examples, which is the second part of the question. So some steps that manufacturers can take are to think about the selection of materials and how these materials are extracted. I should say extracted there, there's a little typo, sorry. For example, polymers and metals could come from recycled sources. Likewise, timber could come from forests maintained by the Forestry Stewardship Council. In addition, manufacturers could adopt a carbon offsetting scheme to minimise their carbon footprint. Blah blah blah. They could also undertake a life cycle assessment to measure the impact of their product over its lifetime. Blah blah blah. Can make a product more energy efficient and more repairable. Excellent. Right, there's lots of environmental issues and what could be done about it. What this answer doesn't yet have is anything related to ethical issues, so don't forget, read the question. In terms of ethical issues, manufacturers should ensure that workers and suppliers are treated fairly. This means ensure they receive a living wage and that their working conditions are safe. You could adopt a policy of fair trade, which means blah blah blah. Okay, so there's a good example of how to maximise your marks. Moving on to section C, designing and making principles. This is worth a lot, 50 marks. And it's likely to start with some high mark questions in which you have to analyse and evaluate a product or compare products. So for example, you might have something like this. Study the images and specifications below. Image A shows a pushchair from the year 2000. Image B is a pram / pushchair from 2018. Lots of information. Right, we're going to have to obviously make reference to as many of these points as we can. The question is to compare the products by analysing and evaluating them in terms of their suitability for the user and suitability of materials. Notice there are 6 marks, so we're going to have to make multiple points here and justify them. That is the tip. And number 12, when asked to analyse and evaluate, give a balanced range of points, positive and negative, and justify your points. So for example, if we're evaluating the suitability for the user, I would give an answer like this. Pushchair AA only weighs 4 kilograms and collapses smaller than pram B, meaning it's easier to move around and store. This makes it more convenient for a person who has to travel around a lot. Okay, great. I'm talking about the user. That is what the question requires. However, pram B has interchangeable cotton seat, meaning that it can be used from when a child is a baby through their toddler years. That's another point. Now we're talking about the user being the child. Great. Pram B also has larger wheels with foam tyres. It's likely to make it easier and more comfortable to move around on rough ground. This means the child is less likely to get upset. There's also under seat storage. You can see that in the image. So look at the images. What do they show? Which is helpful if the parent needs to carry items for the child. Okay, notice how the answer is structured. We've got positives here for product A, positives for product B, and we've got some similarities in the product here. Okay, and that both prams have seat belts. Okay, so a range of points justified, positives and negatives relating to the user. Imagine it was suitability of materials. Well, here, steel frame is likely to be fairly strong and tough, so it should take the weight of a large toddler and be resistant to impacts. However, as a ferrous metal, there's potential it could rust. Another disadvantage is that the nuts and bolts may come loose, meaning that they could fall apart. could be frustrating. So actually, although it's talking about the manufacture process, kind of has some relation to materials. Plan B has an aluminium frame, which would be corrosion resistant, so suitable to exposure to water. Welded frame would also be more sturdy. Both prams have wheels made of fairly tough polymers, although these will wear over time. The nylon seats are also suitable because they're tough and fairly quick drying. That's a general point about manufactured fabrics like nylon. They're not breathable, but they are quite quick to dry if wet. Notice the answer here is structured: positives for product A, negatives for product A, positives for product B, and then some similarities between the products. So again, there's positive and negative points, a range, and everything's justified. Okay, towards the end now. Towards the end of section G, is like to ask you to perform sketching activity, for example, converting orthographic to isometric. Just a note on this. Imagine you had to draw that in an isometric form. Remember, this is laid out in a consistent way, the top, the front, and the end. As a form of communication, anybody should be able to understand this working drawing and be able to go away. So usually it would have measurements, and the way it's arranged is it's always lined up. If it's isometric you're doing, don't forget the top view is always what you would see at that face, front view would be this face, and the end would be that view. Notice there's no horizontal lines, it's just vertical and diagonals. Let me just show you using this little video animation. So don't forget, if you're looking on the top view, it would look like that. Rotating to the front view, it would look like that, and the end view here. Okay, so you can see how it's all orientated. So tip number 13, if doing an isometric drawing, remember the drawing consists of vertical and diagonal lines only, and any circles, as you can see here, would appear like an oval. There is also the possibility you might be asked to draw a perspective drawing. Like imagine drawing that as a 1-point perspective. Now this is going to take you back to probably year 7. If you do a 1-point perspective drawing, you have to start with a flat face. Guidelines then go back to the vanishing point. You then draw the back of the object, and you might need to project lines forward as well, again that go to the vanishing point. You'd end up with something like that. Now, tip number 14 is if you're doing a 1-point perspective drawing, remember to start with a flat face, and all the guidelines go to one vanishing point. Just on this, although it does give some perspective as it shrinks into the distance, it's a bit unnatural looking. So it can communicate an idea in 3D, but it is a little unnatural. If you were asked to do a 2-point perspective drawing, you always start with a vertical line and then 2 vanishing points. The red lines here indicate guidelines, which I'm going to then use to draw a sort of box shape within. So you notice how it's now shrinking towards 2 directions, and then within that you can start adding more detail, another set of vertical lines, and then again guidelines going towards the vanishing points. Build that up over time and you end up with a 3D looking object. More long, more complicated, but it does look more realistic. So if doing the 2-point perspective drawing, remember to start with a vertical line. There's no flat face here, and the guidelines are split between 2 vanishing points. It might be worth practicing that. Okay, I'm going to leave you with this information. Remember again to check out the model paper I've put together on Teams, and let me know if you've got any questions. Best of luck, guys, and hopefully I'll see you in year 13, year 12 or 13. Bye bye.